Well, let's continue our exploration of Halo 2 with, as promised, the calculation of, with the proof that shows we calculated a hash value properly. So I'm gonna start another. Well, let's continue with the same file. I'm just gonna put another file in here, the same project, but another file, and call it hash.is. And in main, we have to do a pub mode hash cargo file. What is it talking about? No. All right, so we're back here, and probably these guys are gonna be needed. Put it here. Okay, so what do we do now? We do a hash test, which is gonna result in calculating a hash value and checking that afterwards. We check that this value is the right one. Okay, so first we have to calculate a hash value. The hash function we're using is Poseidon. The Poseidon is a hash function that was designed to be efficient in zero-knowledge circuits. So unlike Shah or Blake or these guys that are working on bit manipulation and swapping bits around, counting them, and compressing, they have well, you can read about it. It's essentially not an arithmetic function, and they work on arbitrary bit patterns. The Poseidon, since it was designed to work in a circuit, it's actually working on field elements. So the idea is that you have a series of field elements, so it's not arbitrary bytes, and the output is one field element. So basically, the signature would be something like a list of FP, if our base field is FP, and you get a FP at the end. Poseidon is okay. Let's actually pull out Poseidon if we can. Poseidon hash function. It has a few parameters. Maybe this one. It has this notion of a S box, and the S box is I think just something with x power 3 or x power 5. Wow, isn't there something? Okay, this is the research paper. Okay. So you have a design. Where's the drawing? Should be a drawing somewhere. No drawing. No drawing. Okay. Anyway, what we have is a S box, a width and the rate. And the width is called RET, and the rate is the width is related to the RET. So the width is RET plus 1. It's how many FP you expect to compress at a time, and rate is how often you do that process. Depending on that, you're gonna have a certain security level. That impacts how many rows or how many constraints you put on in your circuit. So you choose the parameters of Poseidon. You instantiate Poseidon based on how many hash values you want to compress, how many values you want to hash at a given time. So the reason I'm looking at this is because I'm looking for some good parameters. I mean, the parameters that would make sense. I don't really see them here though. I was expecting this to be easier. Okay, let's just choose some value. First, we're gonna hash two FPs into one. And so let's call x our first random field value. And then y the second one. Okay, so some errors here, probably because, oh no, import hello to a breakpoint field. That's not what I thought would be the problem. Yeah. Okay. Right. So we just have to use this. Oh, we need a random number generator, of course. This is the OS one, the operating system. Okay. So once we have that, this is going to print the x and y just for debugging purposes. X and y, and every time we run, this guy is going to give us a different one. So the main now is going to be, I'm going to change this one to be example 1, and now this is main. Main is going to call hash test and unwrap the result. Why isn't that picking up the errors? OS RNG is not known. Come on, OS RNG should be known. OS RNG is not known if we don't have the RANcorp package. Okay, X and Y. What to use debug. And this should be portable now. Yep. Main. There's one problem with main. Okay, main should have a main. So main will call into hash test. Okay, and hash test has to be public. Okay, that should be here. Hash test. And we have to depend on this. Unwrap. Okay. Okay, error. Not yet implemented. Hash 11.5. Oh, right. Okay, clearly. Okay, so it's just printing two random values every time, B5 here and 4E. So if I run it, it's going to be something different, 38 and 46. Okay, so we want to hash these two values. So we do it the normal way first, meaning without a circuit, and then in circuit. There's the implementation of Poseidon in the Hello2 gadget crate. So I have to go here, and I think it's in primitives. And then this should be hash. Right? And yeah, it's hash. Okay, so hash actually, it's there's a yes, there's an init function. Okay, so this is our hasher. Let's call it hasher. What's the problem here? All right, so we need to give the parameters that f is obviously the let's put it here, hash. The first one is the field, the fp, the element, the field element. Then how many parameters we need? We need 1, 2, 3, 4, 5 parameters. Okay, so I'm gonna put them like that and see 1, 2, 3, 4, 5. Okay, this one. Consider importing this guy, so we have to import this guy. Okay. Alright, so the only one that it doesn't like, we need something here. and that was T. What is T though? T is the type of input, if I remember properly. Let me go to this guy actually. T is what? T width. T is width. T is width, and T should be a constant. Oh, okay, so if we are hashing two guys, we want a width of 3, so this guy should be 3. Okay, now is this one. This one was the rate. Okay, I think the rate. What rate should we use? It's box. Given to table 2. Where's table 2? Table 3. Table 2. Here. 8? No, I don't know. Okay. Okay, I don't know. I'll put the 8 then. Okay. And what else? You need to know S and D. S is easy, the S box. So the S box is something in Halo 2 as well. Halo 2 gadgets, Poseidon, and it's primitives, and it's this guy. This is the S box. Probably should put it here so that we don't have such a long codification. Okay, actually there's only one left. Is not satisfied. Oh, the trade bond FP38 is not satisfied with all the. Oh, it's 2. It should be 2 here. So it should be 2 here. What's the problem? D. 1, 2, 3, D. D is what? Domain. And the third parameter is domain. Okay, I think domain is the stuff that tells the type of input. Maybe if we start using it, it's going to infer the domain for us. So hasher.hash, and the message is X and Y. Okay. Yeah, he has figured out the domain, right? That's clear. Constant length 2. Yeah, it's pretty good. So what's the output of that? The output that is F. Yeah, F is a field value. Right? So this is our hash, and we can print that. Okay, so it should be okay now. If I run this, I should, yeah. So hashing this guy with this guy gives me that guy. All right. So let's do the same thing, but in a circuit. So in a circuit, we know the hash value. So our hash value will be our instance. So I'm going to pull the code before so that we have a model of what we want to do. All right. So we want to do something like a circuit, which would be our hash circuit. X and Y would be 2 known values. This time it's X. This time we do them random. Doesn't matter what they are really, since we are calculating the hash. This guy is not defined yet. Mock prover circuit instance, and the instance is H. This H. Okay. So now we just have to do this circuit for Poseidon. Struct this guy, we know that we have x, which is a value of fp, and y, which is also a value of fp. What else do we need? We need the config. Okay, so I'm gonna create the skeleton of that guy like we did before. Implement circuit for hash circuit. And it's gonna pull the config, which is a hash config. Floor planner is the same one, simple floor planner. Witnesses is the one where I do a derive default, and then I return this guy as a default, and then we have configure and we have synthesize. So the config, very similar to the stuff we had done just earlier, is to have, but this time we are going to use a gadget. We're going to use something that has already implemented all the logic for Poseidon and just need to reuse it. So therefore that would be essentially the config for the Poseidon chip. And that guy is in Hello 2. So hash config would be Poseidon config, which is Hello 2 gadget Poseidon. And I saw this PO5 config has to be our guy. So we have field, width, and weight. So FB 3 and 2, right? To match the stuff we had. Then here, what's going on? Oh yeah, this guy had to be have to have clone and debug. All right, so we're here, and need to know how to use this dude. So to do this, we want to configure that chip, right? So to do that, we call the PO5 chip configure, and that takes meta and state. State is a column advice of width. Then okay, so column advice of state. Let me do state equal column advice, column, well, we can just do meta dot advice column. Let's create one, and we need width was 3, so we need 3 of them. So let's do it quick and dirty. Quick and dirty, just copy paste 3 times, and then that's it. That's good for this one. Then we have partial S box, which is only 1. So this guy is a partial S box meta advice column. And then we have RCA column fixed and RCB column fixed, column width. So RCA is meta fixed column, and 3, we do like 3 times, and RCB is also practically the same thing. Okay, RCB. So we pass all this stuff, and that should return the Poseidon config. Okay, oh, something is wrong. Configure S. S. Okay, S is what? So that's the S box that's in the middle. So same story here. Should be already defined somewhere. So Poseidon. Where is could be? It's not there. Okay. PO5 chip sponge. Okay. All right. So let's take a look at this file then. We need partial box configure port chip. SolidFX configure S has to spec a specification for Poseidon permutation. Okay, so we need to know what stuff implements that implementations. Okay. Oh, this is a P1285S3, so this is the one we want. But that's not, yeah, it should be correct. Okay, so we'll go back here and we are saying, do you want this guy? Okay. What's your problem, do now? Spec is FP324. That should be good. Alright, I'm a bit surprised now. Okay, struct text 3 generic. Oh, okay, sorry. So we are saying that the other guys are inferred, but we have to put them. No? The thread bomb field is specified. Oh, this is not FP actually. That's the trick. It's not FP. It's FQ. Because you, yeah. Is it true though? Struct 1, 2, 3. No. That should be correct. It's just not the right syntax. Okay, let's go back here. And F. What's this S? We are talking about struct profession. Oh, it's configure that has S. Okay, let's go to configure. Oh, the S is below, is after. Right. So this is actually the problem is the parameter, the type parameter is not on the port 5 chip but on the configure. And now kind of on this one. Yeah, so that's it. Okay, so we have that guy, and now we want to put that guy inside our hash config. Hash config, and let's put it on config. And I think last time we had the instance column, so I'm gonna put the instance column here as well. Okay, and the instance column has to be initialized as well. So let h equal meta instance column. All right, so a bunch of things missing. We have to turn equality, support for equality and all this stuff. So let's see, S in state iterator, meta enable const equality on S. Dot con difference, how to clone S partial box, okay, and then RCA, RCB, RCA, RCB, and on and also on the partial S box. Okay, and then also on the instance column. So everything has that. Actually, I don't know if this dude is gonna do it. Maybe it's done in the configure. You can take a look at configure and see if it enables these constraints to support. Yeah, they do actually. They do enable equality for all this stuff. So then we don't have to do that. Let me remove all this stuff. We just have to do it for our instance column, and then we have to do H here as well. Okay, so much easier than the stuff before, since there's no special gate. We're using the gate from the chip, and there is no extra columns or anything. We just have the ones that, well, we need X and Y as well. So of course we need X and Y. X is column advice, meta device, device column. We have Y also, and we have to do this initialization C in well, X, Y, something like that should be fine. Then we do meta dot enable equality on C dot clone. I think that's the same thing as they are doing in this configure. Enable equality in column. Well, they just do a clone iterator instead of cloning inside, but it's pretty much the same thing. Okay, so X and Y are initialized, and then enable equality on them, and now we have to store them as well. Okay, so then we put X and Y advice, column advice, and Y is the same. Alright, so this time I think we're done. Now we need to do the synthesize. So synthesize, we take the layouter, we assign a region. The region would be load secret witnesses. So this is where we put the X and the Y into our circuit, like last time. And this guy is mutable region. Okay, so what do? We have X in the member, and then we have to put it on the circuit. Okay, how do we do that? We do region assign advice. This is X. The column is config.x. The offset is 0, and we set it to self.x, and that gives us X. Okay, we do the same thing with Y. Then it's Y here, and it's Y here, and it's Y here. Okay. Now we want to propagate X and Y out of this function, so we return it as a tuple to the caller here. Let X, Y equal this. Mark. Okay. Alright, so what's the problem? Layouter is not mutable. Classic, now it's mutable. And we are good. Right, so we have X and Y as two assigned columns. And all we need to do is create the Poseidon chip out of the config. So what do I do that? Right, so this guy here, I kind of want to have them already as a use, so that I don't have to do this. And I'm pretty sure this guy has to have a matching chip. Yeah, both chip. So if I take the both chip, it has a construct. So exactly the same pattern as the stuff we did before. The pattern takes the config for the chip, this position config, and it will return the new chip. And with that guy, I have an API to put stuff. Alright, so what do I do here? Config into loaded add input borrow initial state permission. Okay, so which one to use? Oh, that's a good question. Initial state, maybe? Initial state. Probably this one. Okay, so initial state. Namespace init Poseidon. Okay, and then that returns me the state, right? Okay. Oh, something's wrong here. Initial expected mutable reference meet. Okay. That's not the way it works. They want to just me to borrow a layouter. Alright, so what else? Oh, S. And why is S? Where is it S? Initially. Well, I don't even know. See a S here. Oh, here S here. Okay. I thought you would be able to infer from this guy. Power 5 chip. Yeah, very interesting. Okay. Alright, so I have to put the parameters. This is 0, so this is actually 0. Remove this generics. So which generics do you want? I don't even see a S here. Maybe this is not the guy. Okay, I have to read the documentation for Pro 5 chip. So let's go. Side effects, configure, then create the gate. Okay, this is not what we need. We need to know how to use it. Alright, this is the one. Permute. No. Initial state here. Implement Poisson sponge. How do I specify S? It's interesting. Add input. And then what? Get in output. Pull around. Okay, let's go to the crate. This is hard to read. Cargo. Hello to gadgets. Trying to find the place where this is defined. Primitives. This is not chip. Configure. S. Width and range. Start. Permute. This is weird. Why can't you just hash this guy? Maybe there's a helper function somewhere. No. I guess we have really to call init state, then add input, and then get output. Yeah. Okay, what about, is there any example? Oh, this example here, hash, right? Why can't we use this one? Implement blah, 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 verb function hash. The pass, where is this guy? Hash. Okay. Okay. How do we create this guy? Software hash. Poison chip, it seems to be perfect. Yeah, this is what we do. We should use this one instead. Okay, so let's go back here. We have the chip, right? But we're not going to use the chip directly. We have helper function for that. And that is inside hello to gadgets, Poseidon, and hash. And here we can do hash much better. Oh, not hash. So init, and we take the chip. Perfect. Layouter, we have it too. Layouter, yeah. And then what do we get? What do we get? Init, so error. Okay, so we need to have, yeah, we return a hasher. Let hasher be this guy. And what's going on here? Okay, so there's some stuff it doesn't know. S. Okay, maybe you know once I add the like last time, right? We didn't know how to do the this argument here. You didn't know. I mean, until we use it, it doesn't know which one is this guy. But it figured out that it was something called constant length too. So I'm gonna hope for the same thing. Hasher dot hash layouter, same dude, and the message to hash, which is this array of x and y, where x and y now are cells, and it didn't work. Okay, it didn't work. Okay, so we need to have 1, 2, 3, 4, 5. Wow, 1, 2, 3, 4, 5, 6 parameters, and the one it doesn't know is the S. Okay, so no choice. 1, 2, 3, 4, 5, 6 parameters, and this guy was hash is here. Okay, let's call it as this is one out of circuit. Okay, I don't know. Base. Let's call it a hash then. Just h. So that's here is just h. But here's the real dude. And the real dude is yeah, it's not primitive dude. Let's put it here, hash. Okay, that should make him partially happy. So he really doesn't know this guy, and this guy was the S box, which is this guy in this pole 5. No, not pole 5. It was this weird name P. This guy here. No. String count is. Type. Oh no, it's a constant you want. What's the constant? I'm very confused here. 1, 2, 3, 4, 5, 6, and it's the one to last, which is 3 then. Okay, doesn't understand this one either. And now is S that it's missing. And S was the number 2. Should be like this then. And now, wow. The trade bound B blah blah blah, but is not satisfied as trade branch instruction is implemented for profile sheet. Yes. Okay, well, it was supposed to be easy, but okay. So Poisson chip has to implement Poseidon. The question mark somewhere. Okay, that's maybe the question mark problem. No. Oh, it's in them. So it's supposed to click to have a question mark. Right. We found FP. Oh, that's not that guy. This is PO 5 chip. This is PO 5 chip. FP32. Okay, what else? Okay, so S is this guy here. Alright, finally. Really? This is crazy. You cannot infer these guys? Okay, we try to remove. Okay, really could infer these guys. No, not this one. It's pretty strange. I thought you would. I guess not. Alright, so these are the ones that you have to specify because the compiler is not that good. But really, it's just have to make it match the error message. Alright, so we have that. And the result is the hash value, which should be a assigned cell as well. And now we want to have this assigned cell be constrained to be equal to the instance. So hash.cell code should be equal to self dot, no, not self, config dot h on the row 0. And that is, and that's actually it. Synthesize, we load these two guys. Okay, that's alright. So let's run this and see if we have any errors. Oh, it doesn't compile first. What's wrong? Something's wrong. Put chip twice. Yeah. Okay, let's call it as just P by chip. Oh, let's call this guy, leave it behind as hash. And let's call this guy Poseidon chip. And this guy Poseidon config. Unless we have that name already. Ah, I'm stupid. It's not the syntax. As Poseidon config. And here is PO5 chip as Poseidon chip. Okay, so we replace here this guy by this guy, and then probably this one here has to be changed to what's going on here? Where you moved? Where you moved? Where? Where you moved 70? Ah, here. Okay, so just put namespace. Poseidon init. And then one more. One more error. 71. 71. Something was borrowed. Or layout, same story. Alright, so this namespace. Hash. Okay, so now it passes. Let's go with Poseidon hash. Alright, so some stuff that we don't need. Self we don't need. These guys we don't need. We don't need this one. And this one. Okay. What else? There are still two guys. Selector, no. And neither rotation. Okay, and the main. Alright, let's test. Okay, one more. Yeah. That's it. Oh, exhaust one is not used anymore. So I can mark it as unloaded code. Alright, so there's no more warnings. And main we should call hash test, which is this guy here, and it has our logic. Alright, so then we're ready to go. Okay, I'll go run. Alright, didn't work. Not enough columns for constants, so something is not. We need constants. Okay, so where is it? It has to be this dude here. Okay, so what does this guy tell us? In state would be okay. It doesn't tell us how many constants they need. Or maybe something else. Not enough columns for constants. Really, I think it's a problem with fixed. Wait a minute. Column in state, and then RCB. What about RCA? Let's do RCA, I don't know why. That's chain state and chains RCB. Right, so I have to do the RCA. Okay. That's great. So that's this logic here, but we do it for RCA. And really, I don't know why it doesn't do it for RCB. Only for RCB, not RCA. RCA Territor. Okay. Let's try again. Oh, same thing. So these three guys, this guy, enable equality. Maybe didn't do enable equality on partial S box. So we'll do it. Meta not enable equality on partial S box. I know it does on state and RCB. Maybe I should do for everything. Oh, this deal. Here, inequality X and Y. This guy is done by the box. This guy is done here. RCA, we just do it here. CP here. Okay, so maybe it needs some fixed columns. Fixed column. Let's do that. Not column for constants. And I have to also mark them as constants. Meta enable constant on F. Not a rough arrow soluble. So that was the problem, because now we have a different error. This circuit is way too small. 4 is not enough. Let's move it to, well, 5 will be not enough. 8 at least. Okay, it worked. It worked. So maybe we can make it smaller. 7. 7 still, wow, it fits. 6. Okay, maybe 5 would work. Yeah, 5 is too small. So we need at least 6. Maybe 6 is not enough. Yeah, 6 is enough. So 6 is, yeah, it's pretty small. 2 power 6. Well, it's gonna be that. Anyway, this is our hash guy, right? So we are, yeah. So we did this hash function. A bit tedious, but not tedious. But a bit tricky to get the types correct. But eventually we got there. I think the part that was tricky is more like fighting the compiler, because the types were inferred properly, but still we have to specify them. It's maybe something that it will improve, because you could figure out some of the parameters and not all of them. This one I'm a bit surprised because Poseidon chip has already the type. Oh, no, it doesn't have the type. It has the type FP32. So it doesn't know about this box here, the type of this guy. So we have to specify this. But I'm a bit surprised that we have to specify 3 and 2, because this is actually the same as the type here, 3 and 2. And it managed to know the type FP, but not the size, not the width and the rate. Okay, I don't really know why. Okay, that's it. Alright, so next video we are going to do a game. Let's do a Sudoku. Sudoku is a pretty good example, because the rules of Sudoku are basically constraints, because you want to make sure that every cell of the grid has the numbers 1 to 9 only, and that every row, every column, and every section has exactly the numbers 1 to 9. So these are basically 9 constraints per row, 9 constraints for the row, 9 constraints for the columns, and then 9 constraints for the sectors. That's it. Oh no, you also have to constrain obviously that there are solution matches the empty grid, the grid that was given to you. So the given digits. So you have to match that, and you have to match the rules of Sudoku. And then you can make a proof that the solution that is the secret is the solution of your specific instance of the Sudoku problem, but also that it doesn't obviously break the rules. So then we do that next time. All right. Until then, have a good day.